Hi everyone. Today XSS is cross-site scripting. Today we see how it kicks ass. Just let's start with a little introduction of myself. My name is Avishay. I'm coming from Israel. I work there as a security researcher at Imperva in Capsula. Here are my social links. Feel free, if you won't have the time here in this talk, feel free to just reach out and ask me whatever you want. And I'm staying here, so there's no problem. You can just come and talk. It'll be fun. Now, I'd like to know a little bit about you and how we're doing. So just by show of hands, which one of you knows what XSS is? Very good. Who didn't raise his hand? Thanks. Okay. Which one of you ever experienced some hands-on XSS? Popping an alert, at least? That's good. And which one of you is a bug bounty buster? Not yet. Okay, I hope after this talk the situation will change a bit. So I'll go over the basics in short, explaining what XSS is. So this is sort of a vulnerability that allows a hacker to send malicious code, for example, to a web server, and then whenever a client is trying to access the server, their browser, for instance, will render that malicious code inside there, and by this the server actually becomes an unwilling accomplice attacking every client that is trying to reach the certain page that was infected. So this is how it's done, and this is the simple form of a stored XSS. So if, for example, there is a user input that is reflected in an HTML code inside a paragraph tag, a hacker could post alert script there, and if, for example, there is no sanitization of what is the input that is inserted there, a pop-up would be raised. Well, that's nice, not too malicious yet, but actually different payloads of XSS can be used for stealing cookies, for spear phishing, or for any sort of phishing, stealing credentials, and what every malicious black hat hacker wants is steal money. Yeah. So, luckily, this is not what we'll talk about today. Today we'll go over to the most edgy stuff and see some unusual implementations. Well, as my job as a security researcher in Capsula, I see lots of data coming through our system. We have a web application firewall, and I came upon many different XSS attacks. And sometimes it looks like we could split it into two. We have what I call the vector, which is the method of injecting the malicious JavaScript, for example. This is what we saw previously. The vector is like breaking out of the context of a regular user input and inserting your own malicious arbitrary script. This is one. And also there are many filter evasions that have to be done to be able to... This is a good vector, a vector that passes every possible filter that is on its way. And then we have the payload, which is, okay, we managed to run JavaScript, what we're doing with this. So I will use this terminology of vector and payload. So what we'll see here today is some unusual XSS payloads that are way beyond that cheesy alert one pop-up that is used for just POCs. And we'll see some sneaky vectors, sorts of syntactical JavaScript obfuscations, and we'll also see some logical filter evasions. Okay, does anyone recognize what we see in this picture here? What platform is it? It's pretty old.
Myspace.
Yeah, it's Myspace. We're back in 2005. And now I'm going to... I'll tell the story of Sami Kamkar. It's very nice that you had... Did you have a profile? Yeah, I did too. It was very, very, very colorful. Very awful. And so Myspace, for those of you who don't know, was a social platform back in 2005, something like this, in which you could have your own profile, pretty much like Facebook today. But what it had was that you could post some limited HTML. So you could play with the background, and you could make your profile look pretty nice. So there was this geek guy named Sami Kamkar that had tried to pimp up his profile. So he looked a bit around, he said, okay, so I'm going to add some pictures. He added some pictures. He saw that he was limited to up to 12 pictures. Well, this is not enough. He wanted his profile to be pimped up. And he wanted to have many, many friends. And what he did was to find some hack method of inserting an HTML that was basically meant to be filtered. And then he managed to insert his 13th image. Woo! Not too much, actually. He didn't have so many more friends because of that. So he went one step further and said, okay, so I'm going to write a script in which every user that is accessing my own profile would put on their own profile in the headline, Sami Kamkar is my hero, and send him a friend request. That was nice. He had some more friends, but still it was not enough for him. So he said, okay, so I'll just make that script self-replicating. So if someone is watching the profile of someone who watched Sami's profile, they would be infected as well. And at this time, as you may imagine, it raised exponentially, and in 20 hours, Sami got like 1 million friend requests. I think he was very happy, but at one moment he was pretty scared and held his head and said, oh, what did I do? Myspace was down for a bit, of course. And he had, 6 months later, he went out to his garage, his Porsche Boxster was waiting outside, and he found the feds waiting there for him. This was the not so funny part. But the funny part is that he had to do some community service after that, and he drove his Porsche Boxster every day with an orange suit going to some wake site and doing his community service. And what we see in the background is the actual original payload that Sami used for his self-replicating worm. So this was the Sami worm. It was based on an XSS vulnerability, and I think it's one of the milestones of special out-of-the-box uses of XSS. But this is pretty high level, and I think some of you want to see some code, so we'll do it now, don't worry. Stepping forward 10 years, does anyone recognize this social platform? Yes, this is Twitter. What we see here is a self-retweeting tweet. There was an XSS vulnerability in a plugin of Twitter that is named TweetDeck. This was a plugin that is meant for social media managers to manage more than a single Twitter account. And there was a very, very, very simple bug there that did not sanitize at all any sort of script injection. And this is what I don't think if I can call it an attacker. I mean, this is cute. There's a red heart. So what the cute guy did was this script. So let's break into its components. Here we have a script class equals XSS, and then we have this $sign, which is jQuery, right. jQuery is a language that is built on top of JavaScript and is meant for making syntax simpler. There are dozens of them, and jQuery is one of them. So they refer by jQuery to the class XSS, and this gives, and then they go to the parents. Parents returns an array of all the tag parents of the class we are referring to. Okay, so the number 0 is the script tag itself. Are we good? Do you want me to go a bit slower? Okay. Number 1 is the whole division that wraps that script. So we are referring to the whole division, and then we are finding A. This means all the links that are inside. It's an array. The first element in the array, the 0th, is the, I don't know what it is, maybe share or something. The second one is this retweet. We click it. Very nice. But now there's another window asking, are you sure you want to retweet? Are there any comments you want to add? So we go on with this, keeping on in jQuery, clicking the retweet button, and from that moment, we're done. The retweet had been done. But this is not enough, because a true XSS ends with an alert 1. But here we are a little more original in this, and we have the alert XSS in TweetDeck. So there you go. This is an XSS. So I said that this is cute, but I think that this is what every malware developer wants to do, to be able to replicate and to do. We talked in some previous talk about a lateral movement. Well, this is a classical lateral movement. It self-retweets. There are like, I've covered it now, but there are like 70,000 retweets of those still in there, even though the vulnerability was patched. So this shows you the power of being able to inject an arbitrary JavaScript. Now we'll cut the payload part to go to some syntactic obfuscations. Syntactic obfuscations are about not really showing explicitly the syntax that we are running, but sort of evading it. And the reason for making this is that there are many XSS filters out there, filters that don't allow using non-alphanumerics, for example, or filters that find the script tag and block it, or erase it, or block the angular brackets. So this is why lots of different methods of obfuscations appear, and we see lots of them in the wild. I'm going to show you also one of them here. Okay. Welcome to JS Wonderland. JS stands for JavaScript, of course. It's a crazy language, actually. It's so permissive. If you forget to a semicolon in the end, did anyone ever forget semicolon in the end of a line while coding in JavaScript? What happened?
Nothing.
Nothing, yeah, right. So this is quite permissive. There's a lot of implicit casting. If you can write any code you want in a dozen different ways, and it will forgive you. It's like a mother. So we'll see how attackers can take advantage of this JS Wonderland to execute code and evade some filters. So let's build it up from the very beginning. So let's see if we can evade alert 2. Okay, we are beyond alert 1 today, so it's alert 2. Do you think we could pop up an alert without explicitly using the word alert in JavaScript? Any ideas? Just shout it out, don't be shy.
You can append it as a string and then use eval.
Sorry?
I said you can append it as a string and use eval as one example.
Yeah, great. You read my mind. This is what we can do in order to not use the explicit word alert. So here we concatenate the string alert2, and then we use the eval that evaluates that string and executes it. Okay, so let's make it a bit harder. Could we pop an alert without using any of alert's letters?
Yeah.
Sorry?
The \x.
Backslash x?
Right, and then the x values and all those characters.
Yeah, something like this. Here I'm using a function that is a string from car code that translates the character encoding, the ASCII encoding number into the character. And then I evaluate it. I could also use it in the last part, but I just was restricted to not use any of alert's characters, so there was no problem with the two. And without any quotes,
You're almost there, right?
yeah, I'm almost there, but there's also, I wanted to show a different method. It's this. /string/.source returns the string itself. Okay? So these are many different methods of like bypassing explicit words. There's a lot more. But and we actually do see this in the wild. This is a vector that we found in our systems. Quite messy. Let's beautify it. Okay, now we are a bit better. What we see here is an attack that uses actually all these methods we've seen in the previous slide. So the first one is we see that we avoid these explicit strings. Here it's done with the helping function that is later used to concatenate arrays into a whole string. Do you see it there in the back? Great. And also we used many randomized variable names so that the attack could not be signed by its variables, like with a static signature. Okay. What about this? Could we pop an alert without using any alphanumeric character? Sounds pretty hard, because how do we create alert? I mean, we tried, we were close to this when we said, okay, we will use integers, but anyway, for using integers, we need to use the function string from car code. So anyway, we are using alphanumeric characters. It seems almost impossible, but only almost. Excuse me for my language, but there is JSFuck is an obfuscation method that uses only these 6 characters you see here to execute any JavaScript in the world. And now I'll go to the console and show you some of its molecular elements that build the whole language, the whole obfuscation language, and we'll see how it works. Okay, so I see it only there. Let's erase the history. Okay, so what's this?
Empty array.
Yeah, right. It's an empty array. Pretty good, not so sophisticated. We'll add the plus sign before the empty array. The plus sign casts that empty array into a number, an integer. This is 0. Okay, nice. Let's use the exclamation mark before that empty array. It would cast the empty array into a boolean, because we can use exclamation mark only before booleans. And then what that would be? Not 1, false. Okay? The empty array is casted into true, and then the exclamation mark gives the opposite. Okay? How would we make true?
Bang, bang. Bang, bang.
Yeah, bang bang. True. Okay, we're good. So we have 0, false, and true. Let's have some integers, okay? So what we will do is to cast true into an integer. Bang, we have 1. Okay, that's nice. 0, 1, false, true. Let's have 2. And I'll stop there. So true plus true. The plus sign actually casts both of the elements into integers, and then we have 2. Okay, so we could continue just as you see here, and we could get actually any non-negative integer. All right. Okay? So we have non-negative integers, false and true. This is not enough. What do you want to have? Strings. Okay, so let's take false, for example, and add it to an empty array. Okay, so what JavaScript does in this case is says, okay, I have false. This is a boolean. I add an array. This is an array. It doesn't match. Let's do some implicit casting. So the implicit casting is to the type that is castable by both of the elements, which is a string. So here we have the string false, and we could also create the string true. And if we take this string false and take its first element, one is this. Oh, sorry. Then we have A. Okay, so we could refer to any character of the words false and true. So we have any character of the words false and true. We have false, we have true, the booleans. We have any non-negative integer. We're doing pretty good. And so here I'll make a little leap and not show you explicitly how it's done, but we could also reach every other letter, not only the ones from the words false and true. So let me skip that. Okay, so we have every string we want. We could also, of course, concatenate those, but we still can't execute anything. And this is a problem. If you let me run every false, true, integer, and string on any browser I want, I would give up. I don't need this. I want to execute stuff. So how we do this? So here I'll start from the end and then show you how it's done. So this is the constructor function. Okay? I'll move it up. This is the constructor function. It's an anonymous function, and let's see how it works. If here we insert alert2, then we get an anonymous function of alert2, and we could execute that. Great. We got an alert. Okay, that's nice, but we don't know how to make that constructor function. So we'll take an empty array, we'll refer to one of its functions, say filter, okay? And this is the function filter. Let's refer to its constructor. As you remember, we can use all these letters. So this is the function. Now all we need is to call alert2 with a string that, as you already saw, we can also use strings here. So here we use only strings, brackets, parentheses, and we get an alert2, and of course that this can be executed. Okay, so I won't show the whole explicit way of making this, No, I will show it. And we got it here. This is how an alert 2 can be created by not using any alphanumeric character. Okay, that's nice. There are many different methods of non-alphanumeric obfuscations. And I'll show you some of those. Here you have the links to the automatic obfuscators. The reason I want to show you this one is that it's slightly different from JSFAQ. It does use some of the concepts there, but here we have a prefix and a suffix. This is what builds the basic language. And what's in the middle is the payload itself. And guess what it does? Alert 2. So the basic building is creating an element that is this $sign that has many keys and values inside. And every key refers to a value that is something else that's useful for the language later. So we have the constructor function that is in $. We have the return, the 7. We have some numbers and letters and some important words. And by using this, what's in black is popping an alert 2. Okay, this is pretty much similar to the one in the previous slide, but here we are using even crazier characters. We have some Greek letters and some Japanese smileys, and so this is very nice. And actually, you could perform it if you look into. You could use any set of characters that you would like, and so this is pretty crazy and hard to filter. Okay, so up to now we had only syntactic filters. We saw many forms in which a syntax could be performed differently. What we'll see now is some logical tricks. I wouldn't call this obfuscations, but it's sort of outsmarting filters. So the first method is mimetism. Mimetism is making code appear to a certain filter as one thing, while actually it's another thing. This is pretty obscure, I know, but with this example, you'll understand it better. So let's assume you would not want a user input to contain an HTML filter, and to contain HTML content with the JavaScript inside. Okay. So what we would do is just to make a filter that looks like this. This is regex syntax. So we have opening angular brackets, and while these angular brackets are not closed, we'll look for alert or for any other JavaScript payload, and then look for the closing of those angular brackets. Does it make sense? This would block something like open script tag, p, or image src equals something something, and an event handler on error equals alert 2. Are you with me? Great. So this looks like a pretty decent filter, but this payload here would actually trick it. Let's see what we have here. So the mistaken interpretation by this XSS rule would be, hey, okay, we have image, we have something, something, something. There's the HTML tag ends here where I see the angular brackets. And then all the rest is just content within the tag. There's no way of executing JavaScript inside, so I'm perfect, no problems. But actually, the real interpretation is that this src equals angular brackets inside double quotes is just nothing. It's just a wrong image name that would raise some error, and the error would be caught by this event handler here on error, and this would pop an alert. too bad. Filters have to think out of the box and not only inside the box. Here we have a different method of execution of a vector that it's a single vector that works for many different contexts. One of the challenges when we are looking into where do we have the possibility of running XSS is understanding the context. Am I running inside an HTML script as an event handler? Wow, that would be perfect. Am I running inside between HTML tags or between paragraph tags like we've seen in the first slide? Am I running inside jQuery? Where is my input reflected? And polyglots are coming to solve the problem of trying so hard to understand the context by using a single payload that is valid for many different contexts. Here we see one example that is valid for two contexts, as we'll see in the next slide, but actually you can find polyglots that are valid for 7 or even more different contexts. And this is good for some reasons. One, it's like a no-brainer. You just put it there and you're good. And the other one is that it saves you time if you are a pen tester and you are looking for many different ways of making XSS attacks or like POCs. Okay, so let's take the polyglot that was in the previous slide and insert it here. Let's assume that we have some input field. Okay, so we have this input field in which you enter your text and your value is there, is reflected in the violet part. If we insert our polyglot here, then the value, or the double quotes of the value would end right away, as you see in the white square. And then we would have twice the same event handler. OnClick equals alert2. Okay? So the second one would just override the first one, and we are good. We have an event handler, and an alert would be popped. If you are running in a single quote context, and our payload, our user input is reflected in the same place, then we could insert exactly the same payload. And here, the interpretation would be slightly different, but the result would be the same. So the interpretation would be that the string inside the value goes on until there is a closing single quote. And then we have OnClick alert 2 again, and an alert would be popped. So here we are done for these two parts. And I also would like to mention some concept that is named blind XSS. Blind XSS says you don't know in advance where your XSS is, where your JavaScript that you inject is going to be executed. You just can't tell. It's sometimes reflected in many different ways in which either the hacker or the pen tester cannot know in advance. So the technique is just to spray your vectors everywhere, make the JavaScript access back some server that you have, and if you see some notification, you know that XSS worked. Okay? So in these blind XSS methods, polyglots are really, really important and make a really good work. Any questions this far? Okay. So let's assume that we would know wherever a user could place input and block it perfectly. 0 false positives, like a perfect machine that knows what is a malicious attack attempt and what is a benign user input. We could think that if we had that magical machine, we would be good. Like, okay, we are sanitizing every possible user input inside our input fields. Great, no problems. But actually, it wouldn't be like this. And as an example, we'll take a vulnerability that was published a few months ago by David Valaches. This is a vulnerability in an SEO plugin of WordPress. And here we see the vulnerable code. Okay? Does anyone see what's problematic with this code? I know it's a bit hard. Okay, and now? Okay, here we have the HTTP user agent and referrer that are reflected directly to an admin panel. Jackpot. We could just construct an HTTP request in which the user agent is crafted or the referrer is crafted, or both maybe. And without even having any user input, no input fields, no nothing, no user-generated content, static site. Anyway, if someone has a sort of a log or an audit of which are the user agents that are accessing your site, they would get this stored XSS, and it's an admin panel, so double jackpot. So I think the lesson learned here is just to think out of the box, expect the unexpected, all the things that every security guy or girl should know. And now as we're going to the end, I would like to share with you a case study that we had in Incapsula 2 years ago. We had this customer that was complaining. I don't think he was even complaining, just mitigated his DDoS, a DDoS that was triggered him. A real bad DDoS. Lots of GET requests, tens of millions of GET requests, originating from more than 20,000 different clients. A pretty tough one. And as we did the research to understand what was its origin, we found that it was based on XSS. So you must have asked, why is that the DDoS t-shirt that I'm wearing? Actually, I saved the surprise for the last part. So how it worked. The DDoS was, the XSS vulnerability was in sohu.com. You might have never heard about this site, but by then it was number 27 in Alexa ranking, number 8 in China, of course. So it's a Chinese platform, very, very popular there, that is used for streaming video content. Now the hacker found that there is a reflected XSS inside Sohu in the comment section. You could add some modification to the image that you are sending, and by this create an XSS. We'll see the payload later. The hacker would send their malicious comment to the site, to a certain video, and then whenever this comment is reflected to a user's browser, if they trying to access that video, they would get the video as well as that malicious script. The JavaScript runs in that client, and guess what it does? It repeatedly sends GET requests to a certain victim that the hacker chose. Well, it was 1 request per second. I think I can handle manually 1 request per second. It's not too much. But imagine what happens when you are a huge site, a very popular video with thousands of views per moment, this would cause a real bad damage to that victim if he wasn't protected by encapsula. Okay. Yeah. So here we can see, I know it's a little small, but we can see the attack itself, the payload itself. I'll tell you what you see here. There's an onload equals $ get script, ta 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 ta. What happens here is that the hacker could modify the image name of an image that they send that is reflected on every comment, and then this would get a script from the attacker's CNC and execute it. That is a JavaScript that inserts an iframe that sends those repeated requests. And now everywhere that there is this comment or a comment that uses this picture, the attack would be running while the video is running. Okay, that's nice. The attacker would also choose the best strategic places in which to put this attack. I mean, if there was the same vulnerability in YouTube, we would say, okay, so let's put it in a Beyonce video and not a video of my friend showing some pictures of his cat or something. Now we'll see some demonstration of how all this worked. First, let me introduce you all the fictional sites that are here. Of course, I didn't use Soho itself and didn't use the original targets. So we'll have Co-op Bank, that is the site that would get the DDoS attack. And we'll also have Super Duper Times, that is a site that has a comment section that is vulnerable to XSS, and this would play as Soho. We'll also see Co-op Bank from its other side, from the access log side, to see how the requests are sent there. So let's start. Sorry. So here we see Co-op Bank. It's a very famous bank. It has lots of branches all over the world, fictional, of course. And if we search for San Juan, we see all the branches that include the string San Juan. Okay, this is a MySQL that's running behind. Very nice. And here we also see the request itself, the GET request that is sent to Co-op Bank. So far, so good. This is Super Duper Times that plays as Soho, as you remember. And here in the comment section, a legit user, that's me, would say this is a nice article. And the comment would be stored in the database that is behind Super Duper Times and then be reflected to any user that looks at that article. What a hacker would do is, of course, say hacked lol, and post also a script. What this script does is it sends those GET requests we've seen once every 300 milliseconds to Co-op Bank. If we are looking at it, it looks as nothing, it looks pretty benign, but if we go inside, we can see that we have a script running, and this script would run whenever, for every client that is trying to access Super Duper Times. Guess how Co-op Bank feels now? Not so good. We can see that it starts to get these requests. There's a little delay because of just resource allocation, but soon we will see it. So here we have all the requests that are sent to Co-op Bank server. Now let's see what a regular client that is just trying to make a search in co-op server would experience. We're searching for branches in Berlin now, because that's my connection home. Too bad. Too many connections. Forget about your bank. And that's what DDoS is about. It's just denying service from legitimate clients by a hacker. So we are at the end of the presentation. I think let's go over what we covered. We saw some vectors, that is how to make an XSS work and evade filters in different techniques. And we also saw a bunch of really unusual and esoteric payloads. And there was the Myspace, the self-retweeting tweet, and also the XSS for DDoS. I think the message is that we are never safe, and the protection is something that, just like learning security, you always have to be up to date, you always have to understand what are the trends and what have you not thought about yet. Thank you very much. My name is Avishay. Feel free to reach out either by one of the links here or just to come, and I'm staying here, so no problem. Feel free to talk to me. Any questions?
The attack takes place when you upload the comment. The attack is taking place when people view the comments, or right after you upload the comment?
No, when people view the comment. It takes place, it executes on every browser that is currently opening that page. Right? As long as the page is open. So this is why the attacker chose the longer videos and the most popular ones to execute an attack as long and as strong as possible.
Thanks.
Yeah.
So in the beginning you mentioned cookie stealing. Is that a similar mechanism where you send your cookies to a third browser and you're in the comment or the user agent or something like that?
Yeah, exactly. It's just sending it. We could think that if we have the ability to perform XSS on a certain web server, then we couldn't do much because we are only in the browser context. We couldn't just break out or privilege escalate, not by... anyway, it wouldn't be that trivial to do this. So document.cookie is pretty simple. We could send this document.cookie to any site we want, and this is the cookie stealing method. Thank you very much. Thanks for coming.